In this section, we're going to take a look at radical expressions and functions. So first, let's start by talking about what a radical means and what the different parts of the expression are. First up is the basic form of the expression, which goes the square root of a number, a. And the parts of that are this little device right here called the radical. And then there is this little fella inside the radical called the radicand. Now it's important to note that the radical refers to this actual symbol here, which without an index, if there were a number out here, that number would be called the index, which without an index means the square root. And with an index, it would be the root of that index. So if there were 3 there, we'd be looking at the cubed root. If there were a 9 there, we would be looking at the 9th root. And so let's take a look at one actually. It's the 9th root. And I don't even know a number with the 9th root. So I'm going to say x to the 36th power. And what that is asking is, what number times itself 9 times will be x to the 36th? Well, we're not going to spend too much time on that particular problem right now, but we will look at roots like this. For now, what I'm concerned about is square roots. So if I have a number here inside of a radical, and I ask you what number times itself, what it means is what number times itself is a. So let's take a look at some actual numbers. Let's say there's a number 81, right? And I want to know what the square root of 81 is. Typically, when we use this notation, if we're just talking about expressions, what we're looking for is the principal square root. And by principal, what I mean is the non-negative square root. So the square root of 81 is 9. Because when I were to square 9, 9 times 9 is 81. Now we know for a fact that also negative 9 times negative 9 is 81. But the radical, unless we have it in an equation, is asking for the principal square root. I might ask, what is the principal square root of a number like 64 over 36? So what is the square root of 64 over 36? Well, that's the same thing as saying the square root of 64 over the square root of 36, and because both of those are perfect square numbers, the square root of 64 is of course 8, the square root of 36 is 6, and then again we can even simplify that to 4/3. So basically what we're doing is we're unpackaging a phrase like this, right? The opposite function of this phrase here is to take the square root. And so the square root of a squared number is just that number itself. Now there's a couple of very important things to understand. First, and let's scroll down just a little bit for now. The first thing to know is that all numbers inside the radical must be non-negative. If we are talking about a real number, for instance, up here I showed you the square root of 64 over 36. Up here we were looking at the square root of 81. Well, can I, or is it possible to take the square root of a negative 81? If we're talking about a real number solution, is there a number that times itself is negative 81? Then the answer is of course no. But we will by the end of this chapter, take a look at ways of notating this using complex numbers. But let's just say for now that what we really care about is this notation itself and the parts of the notation. What is the radical? What is the radicand? And what does it mean to take the square root of a number here and here? What does it mean to take the square root of a square number? What it does is it packages that. You've been doing that when you were solving your equations like what is the quantity x minus 3 squared minus 9 is equal to 0. When you solved that in your practices, you were taking advantage of this fact, right? By moving the 9 over to that side, making it positive, and then taking the square root of both sides. You were taking advantage of this fact.